Okay, so I'm going to bring this up, PowerPoint up, right? Okay, so today we're going to see Module 7, Designing Web Scale Media. Okay, so what is in this module? Part 1, storing web accessible content with Amazon S3, caching with Amazon CloudFront, managing NoSQL databases, storing relational data in Amazon RDS, implementing a serverless architecture with AWS managed services. Discussion 2, we might do it another moment. Okay, so upon completing this module, you will be able to discover database services for storing and deploying web accessible content, quickly and cost effective, depending on your needs. Identify the key features and benefits of Amazon S3, CloudFront, Amazon RDS, and Amazon Aurora, and all Amazon database services, and compare SQL with NoSQL databases, and perform a lab, which you already did, implementing a serverless architecture with AWS managed services. Okay. By the way, I might start giving you access to the platform, a platform for exams for this class. Probably do it tomorrow or Wednesday. So you can just exactly as the class, like the class in the morning, I'm going to give you access to a platform for your solutions architect exams. Okay. So this is the reality of web-based applications. Your applications being unavailable. That's something that happens very frequently, and that comes with a lot of losses in revenue. And of course, that affects the user's experience, which in turn affects your customers' loyalty, right? So if you're not offering a website that gives them the speed they want, or the ease of getting the resources at a decent, latency, then you're going to lose those customers. That's one of the problems that you may come across when your website's very slow. All right, so something about any consuming society like the United States, for example, is that people have many choices, right? There are many websites like probably like yours, so they're not exactly the same, but basically you may offer the same products as other websites. So it's very good to retain your customers when they come to your website, and that includes a very attractive, appealing, graphic user interface. But also very important is the speed of the website, right? That's very important. Some people, unfortunately, don't have the patience to wait, and they just leave and go to another website. As simple as that. So performance translates to high page views, better customer experience, and higher conversion rates. Just in case you're selling, right? You want to convert a customer into a buyer, right? Then your website has to be fast. It has to offer something that people want, but at the same time, it has to be fast. One of the ways to assess a website is by the conversion rate. Okay, if your conversion rate is high, then your performance is good too. Okay, so for example, 1 second delay in a page load time, that represents 7% of losses in conversions, and that's 11% fewer page views, and is 16% decrease in customer satisfaction. So that was a study that Strange Loop, this company, they did, and it's pretty accurate. Okay, it's it's like I said, you have delays, you lose customers, and when you lose customers, you don't have buyers. And when you don't have buyers, you have people don't take a look at your website, and then people are not satisfied. So this is not what we want. Unfortunately, we have AWS for that to solve that problem. Okay, in case of a website with a heavy workload, then AWS has the solution for that. Okay, so we have here a website. This is Amazon, right? Amazon.com. First thing, number one, the website is secure, right? If your customers are providing personally identifiable information, right? PII, they might not provide it if they don't see this little lock here. Okay, this is very important. So your website needs a certificate for sure. Right? If it is a personal website like your resume online, like a personal profile, I mean that doesn't matter at the end of the day, because customers that just come to your website to look at your website, they're not introducing any information, they're not buying anything from your website. So that doesn't matter. But if you're selling products and you are collecting customers' information, you better have a certificate. That's very important. Okay, so in this website, they have a dynamic website, right? They can have a user input right here where you can search for information. Okay, if you take a look at Amazon website, it's not that fancy. Amazon is not fancy. It's not a fancy website with a lot of colors and a lot of functionalities. It's just a website for reading and buying and reading and all that. But it meets the needs of the customers. It fits the purpose. Okay, that's what this is all about. Just accomplishing your goals, right? Which is bringing more customers and having more revenues for your business, right? And retain customers. You just make customers come back to you for more. Okay, that's very important. And a website and the performance on the website plays a major role in this, business, right? So it's a zero time to live, TL, right? Time to live. Okay, and they have a static section that you can see in an iPad. It can be cached. That information can be cached there. They have a video section here in this website. So as you can see, it has a lot of components that, when the page loads, they might make the website a little slow, right? So you have to have something in the background, something behind the scene, working to make all of these components load real quick for a better user's experience. Okay, so here we have a pattern for storage web assets. So we have here a static assets, which is the assets that are going to change, such as text, images, and video content that can be stored in Amazon S3. So they're not gonna change, right? Always the same. By the way, Brian, how's your website coming along?
It's coming along. I mean, to be honest, I've spent more time studying for the AWS certs and trying to finish my other school since I graduate next week. Than actually working on the website. I've kind of pushed it off a bit.
Yeah.
But I'll let you know at the end of the week how much, what I've added to it.
Good. Yeah, that's not a priority right now. It's certifications are first. Good. That's good, man. At least you're working on something, that is, where you can implement your knowledge. Whatever you have learned, you can implement it. That's good.
Yeah, I mean, I was gonna use it primarily as like a kind of like see what I can do kind of thing. Like instead of when you go to like a potential interview, you could just be like, hey, if you want to see what I've done, you can see my work, and this website's my work, so on and so forth.
Yes. Good call. Okay, so let's consider this pattern. We have a problem here, right? So we might need, we won't have a problem when delivering a large file from a web server, like, it can become a problem in terms of latency. You know, uh, it might be a little slow when delivering those files to customers. Probably they want to download something from a website, or probably they want to watch a video that is embedded in your website, and they might not be able to watch it quick. I mean, it's just, I have some latency issues, like the video is a little delayed or something. That may happen when your website is not performing well. So another thing, that probably the content generated by the user needs to be distributed across all your web servers. You may not have the capability for that. Probably you have only one server, right? And you have an S3 for static assets. And this might be the entire region with probably an availability zone here, probably, right? And that might cause some delays. So the solution is, let's say you want to probably all the static assets, you want to put them in S3, okay? And everything that has to do with HTML, CSS, images, and all that, you can put them in S3, right? So the object that's stored in Amazon S3 can be accessed directly by users if set to public, right? So if I give you, for example, okay, this is just a Java. If I give you something like, for example, I want to, I have my website here. So if I give you this, guys, if I give you this link, right? This is gonna be exactly the same as if I type my classroom that site. So if I give you that, it's in the chat, and if you just copy and paste it in a browser, then you're gonna get to the website that I created. Okay. So this is the way that you access this content in S3. So if you just select Cognito here, it gives you information about Cognito. Right? This is exactly what you see in Amazon AWS. If you just compare, Cognito, right? It's exactly the same thing. You see, all the same thing here that you can compare with the website that I created. Okay, same thing using Bootstrap. Okay, and I was playing with this, like for example, I wanted to show this in class, right? If I want to see my information here, I can do it. But basically, this website is not a website that is going to be used by a lot of customers. Probably, if I just optimize it, really, really well, probably my students will use it just to get to the resources faster than going to the console or anything. If you want to connect to AWS, here. But it doesn't have to be optimized, or have any caching features behind it or anything. It's just basically, at the end of the day, it's just a static website, nothing else. Okay. So, and by the way, that it's set to public. If I come here and I take a look at the permissions, it is a public website, public bucket that has this bucket policy. right? And it's allowing, the fed is allowed. The principal is everybody. When you see a star, that means everybody. And this is the idea of that. And basically what it's doing is allowing everybody to get an object, by the way, access the objects, right? The website and everything inside, right? When you see here /star, it means everything that is inside the bucket, everything that is inside the bucket, right here. Everything here is after that /star, okay? This is, for example, let's say www.classroom.site/static/ whatever is inside the static /CSS / this. That's what it means, /star. Everything after the slash, it's just captured in that policy, right? Buckets policy is the document that is written in JSON, right? In JSON format for you to give access to your bucket. Okay. Very good. So Amazon S3 performs backups in at least 3 different data centers for extremely high durability. Okay. You don't have to enable that. That's enabled for you, right? The backup is already enabled for you. That's why S3 is one of the services that scales automatically, right? It will scale and replicate your data in 3 different availability zones. Okay. So we have to choose a region, right? And when choosing a region, you have to see how performance depends on proximity. You know, you have to see how that architecture is going to be close to your users, right? The closer you are to your users, the lower the latency is going to be. Okay, that's very important. Okay, so if your user are mostly in the United States, so you better go for probably, you know, let's say if I have an EC2 instance here, you probably go for one of these guys here. All right, the US 2, 1, US East 2, and US East 1. So if your users are in the United States, right? Then if you have users in the United States and then you have users in Asia, Hong Kong, for example, and you have users, for example, in Sao Paulo, you have users, for example, in London, then you have to develop another architecture. Then you have to go more global. Then in that case, then you might want to get CloudFront and then get Route 53 to be more global. Right? And then when you use CloudFront, then you're gonna implement edge locations and all that. Right? So also collocating with compute and other AWS resources affects performance. So what compute services are you using, right? And you have to see if they are available in that region. That's very important. Okay. Cost is very important too. How much they're gonna cost you, right? So availability, cost, and type of service, right? Very important when choosing a region. All right. So now when naming the buckets, your bucket name has to be unique. It has to be unique, right? That's why it's highly recommended to choose, for example, if you're hosting a static website, it's very recommended to use your website, right? The website that you're trying to build, that domain that you created, right? Because this is unique, right? Unless there's someone else that wants to mess up with you, right? Or someone that wants to make fun of you or just do something bad to you. I'm gonna choose this one so that Carlos cannot choose this one. I don't know, something like that. But if people are acting normally, okay, if they're acting normally, I don't think anyone is gonna choose this name. Okay. For example, Brian has his own. I think I saw it. Is his first name and last name .com? Is that what it is, Brian? Ryan, is that what it is? Are you here?
Yes, I am.
Yeah, you're using your first name and last name, I guess. .com, right?
I called mine Brian's World. But yeah, I'd created two buckets. One that was just the name of the website and then the www to it.
Oh, good. So it has to be unique. Keys are represented as strings, the key, and the namespace is partitioned by a prefix with multiple partitions to store object keys, right? The object key is usually the name of it's the name of the file, right? The key is the name of the file, and the value is the content of the file. Now, when you see a prefix, that is a folder, right? It's usually a folder because when you have the S3 bucket, you have folders inside, right? You have folders inside. That's also called a prefix. And you could create a folder here. If you click here, you'll create a folder and put some content here, right? You can encrypt that folder. So whatever information that it is uploading in this folder is going to be encrypted with server-side encryption, right? Using the advanced encryption standard 256. Okay, or simply you can use KMS AWS with this type of keys, right? That is managed by AWS. Okay, that's something that you can do when you encrypt the files. So the object names you choose dictate the key map. Okay, whatever key map you have, like the key and the value. It's good to be consistent with all the naming of this objects and prefixes and everything inside your bucket, right? So Amazon S3 is object file storage. We know that already, right? You want to your bucket capable of routinely exceeding 3,500 put, post, delete, or 5,500 get requests per second. Okay, so that bucket is going to be available to do this, right? Right, and then they increase your read and write performance exponentially. So this happens with S3. Now, if you want to know more about that, then you can click on this in your PowerPoint. I think, guys, can you on your pod? Can you click on that? Is that clickable on your pod?
No, for me,
It is not clickable.
no.
No, it's not working for me either.
No, it's not.
Okay, one moment. Yes. Okay. All right, so I'm going to paste this on the chat. All right, I put it on the chat. That's the best practices for design patterns optimized in US3. Okay. Naming rules starts with reverse stamp times timestamp, epoch time, or counter. Okay. First 3-4 characters are critical. Randomize prefixes to be distributed across buckets partitions. Okay. Good. Okay. So a prefix is like a partition, like a folder, have you ever heard about epoch time? Never? Never, guys?
I'm sorry?
Have you ever heard about epoch?
Yeah, it's
Yes.
the beginning of when like computers think time started, which was like 1970, January the 1st.
Correct. So today is it's this is not correct, right? So right now is this is GMT, right? GMT is like 4 hours. It's like 4 hours ahead or something like that. Maybe more because it's 9:28. Well, sometimes computers, they it's difficult for example, database to read a date in a format. For example, like this one, right? So what people do, especially full stack developers, is they use this number, right, that represents a specific date. So this number is Monday, 5/18. So this is the month, not Monday. This is the month. So this is 18th of May, 2020, right? So that's, and this time as well. So this is this number, right? Now, I have to have in my program some functionality that translates this into normal standard date format, right? Because people cannot read this. I mean, if I tell you today's date is 1589837282, you're gonna ask, what the hell is that? I don't know what that is, right? So we have to be able, whatever software we're using, we have to have some functionality in place that translates this into standard format for dates. So epoch time is just this number here, okay? It's a Unix timestamp in second milliseconds, and that, so this is timestamp to human date. So we do this in human date, is this. Like we said, there's 4 hours in advance. What time is right now? It's 1:30. It's 5:20. It's just GMT, right? Or we can have this and turn it into epoch. Okay, so from humanly readable date into epoch. All right, so you can use this also to identify your buckets. You can use a timestamp, like a date in front of your bucket name, it's you can do that, right? Or a counter, like 3, 4, 5, 6, 7, whatever, just to identify your buckets. Because when you have 100 buckets, it's going to be a little messy, it's going to be chaotic. So you have to be organized, and the naming is crucial, the way you name your resources in AWS. So for example, the partitions, AWS automatically, S3 partitions your buckets according to the prefixes of your file. So you have the album1, album1111, you have all these, partitions, and then you have inside, you have photo 1, photo 2, photo 3, photo 4, photo 1, 2, 3, 4. So this way here, okay? So that's the way it partitions that. So a partition 1, a partition 2. So each bucket contains multiple partition to store object keys. Amazon S3 automatically, we said before, partitions the files, right? And it does that according to the prefixes. So the keys partitions, bear with me guys, this mouse is so sensitive. So the keys partition the bucket key name space, and then they define the partition key are stored in. Additionally, keys in Amazon S3 are partitioned by prefix. So this example shows 2 partitions. The partitions are album 1 and album 2, which have photos, right? If you start having more than 300 requests per second, you can create a hotspot, because many of these albums are named in the same way. So they are in the same partition because they are in the same folder. So a hotspot, what it means is a partition that has a lot of requests, and then it cannot cope with that. Okay, so it's better to have several partitions. Okay, as you can see here, they have the same thing, but the partition is different. Okay, but they have the same files. So it's you see that you have a lot of traffic where you can create more partitions. Right. So Amazon S3 automatically partition your buckets according to the prefixes. So we saw that before. It If a process requests photos for mammal 1, all the requests will go to the same partition, right? But this is the anti-pattern, right? So if you store thousands of objects in Amazon S3 bucket, this file naming convention could limit partition performance when Amazon S3 partitions your bucket. Adding a random value to the key can provide higher performance. Okay, so if you issue queries against Amazon S3 bucket that store a large number of objects and the data is not partitioned, these queries might affect the GET request rate limits in Amazon S3 and then lead to Amazon S3 exceptions. To prevent the errors, you should partition your data. Additionally, consider tuning your Amazon S3 request rates. For more information, you can see the request rate and performance considerations in Amazon AWS Amazon documentation. So this is something that you can do to make more performing, highly performing. So you can add an hex hash prefix or any base to the key to reduce the chance that a request reads from the same partition multiple times. So in this case, we have different pictures, right? But then we have the same partition, right? We have the same partition here, right? So if I'm asking for picture 1, then it's gonna read the other 3. I don't want picture 2 or picture 3 or picture 4. So that makes your S3 bucket slower, right? Because you have to go through all these guys here. But if you have a specific hash here, like hex hash in front of the partition, then that's gonna be faster, okay? So if a process requests the first 4 photos, the request would be split between the partitions, okay? Now it says here, note this example partitioning scheme is for demonstration purposes only. Your Amazon S3 bucket may be partitioned differently based on how its contents are named. So like I said before, the naming has to be consistent and it has to be meaningful to the company, policy based on the company policies. Okay. Okay. So what if your buckets is constantly under load, right? To more easily retrieve your files, maintain a secondary index and hash all key names, okay? So Apple ID, for example, application ID 38229 for 911, and then you have a month here. So you're making even this more, specific to make this, faster. So the reason why you do this is because you don't want your application to scan the whole thing, right? If you're specific, if you just, make this a little more specific, like narrow it down, right, this way, then it's gonna go straight to that particular file because you have a unique values here, like the application ID and the month, right? There's only one, actually you have 2 repeated 4s here and 2 repeated 3, but it doesn't matter because the month is not exactly what it looks for. It's looking for that specific secondary index like this one, right? So it's looking for this one, right? Like probably the primary index, right? But then it goes to the other one, right? To make it even more, specific and look for that. And this takes place in an Amazon DynamoDB table that you can create a secondary index to make your data perform better and the requests can be, served quicker, right? So this is one of the techniques, adding a secondary index. You can have something called a global index too, but that's something different, okay? That's also for improving the performance of your DynamoDB table, all right? But for now, we're talking about secondary indexes, and what it does is just, it makes this more easily retrievable, right? and you can use the prefix and all that. And that way it creates a secondary index, which acts like a legend, right? That points to where all the files are located. So that's very important. So you want to make your S3 faster, you can have this hex hash prefix or any base, it says here, any base. So whatever you want, right, that makes sense to you, right? You add it to the key, right? And then apart from that, you can add a secondary index. So that's gonna make your, your database, like I said before, perform much better and quicker. So Amazon CloudFront is a content delivery network, a CDN. We have a lot of CDNs, right? But this is the one that Amazon or AWS uses, right? So your content can be cached all around the world. This is very important if you want to be global, right? If you want to be serving your content to users around the globe, then content CloudFront it's a service that you can try, right? It's gonna be a little pricey, but when you have a company of this sort, like serving content globally, they're probably a company that's making some money and they can afford to pay CloudFront. Okay, so geographic proximity means lower latency. We know that. Better user experience and less stress on your core infrastructure, right? So when you use caching and in edge locations, your application is not going to be that stressed with a lot of traffic, and the workload is going to be better distributed because next time when the customers come back for more information or for the same information, you don't have to go back again. You're going to have to go to the database. You can simply retrieve the information from the cache location. Okay. So some key features. So it's optimized for TCP, for this protocol transport and IP for the network path. It keeps alive the connection to reduce round trip time, right? It keeps it alive as long as you want. You can set the time to live of the cached information in CloudFront in the cache location. You can set the time to live, and then when the information becomes stale, it would just disappear. Okay. It has SSL and TSL termination close to viewers. Okay. So this has to do with the connections that are made with, for example, elastic load balancer that it has termination, TSL termination. When the connection it's just terminated, it would just connect to something else. Okay. So you have some post and upload optimizations. So when customers, they just post or upload some files, this has the capability of doing really quick and faster, right? It has some routing, latency-based routing. By the way, this is one of the routing policies that Route 53 has, latency-based. And it has regional edge caches to work with customers and cache the information. So best practices for caching. Here we have the Antipattern, right? So the implement caching on multiple layers of an architecture. It can reduce cost and latency and increase performance of application. Here we have Amazon S3 with data. So 3 requests of equal latency and cost. Okay, so the customers are just requesting this directly to Amazon S3, right? And after 3 hours, if after 3 hours, these customers, they want to request the data again, the same data again from they have to come here again, right? Whereas in the best practice section, customers, they come, retrieve the information from, they come to CloudFront, right? So CloudFront retrieves information from Amazon S3 and then and then the information requested is going to be cached in an edge location, and then the customers, when they come back again, they don't have to go all the way to Amazon S3, so they can cache it from here. Just get the information from here. So the second, third, and nth requests are at a lower latency and cost, right? Because you're getting from the edge location. That's very important to remember. You cache static and reusable content. So we have all the users here. They get the information from CloudFront, right? So we have the TTL here, which is 0, right? Because the customer, the dynamic content is here and in this CloudFront. And then actually this is, sometimes I get a little, this is, sometimes I get a little confused with the image, the icon of the service. Okay, these are Amazon EC2 instances. Let me see here. That's okay. That's Amazon CloudFront. So we have here this Amazon CloudFront, and then it's the dynamic content here, or you can have it in your own premises. So the time to live here, it's just 0, right? So basically, the information would not be cached, right? Because it's static. Now, here we have a time to live 300 seconds. That's 5 minutes, right? So the information is going to be retrieved from here. You're just getting a JPG file from this Amazon S3, so static content. So it's going to be there cached for 5 minutes, right? Just in case someone else wants to get that particular file. So it's going to be there for 5 minutes. After 5 minutes, boom, it's gone. Or you can do this also in the on-premise data center. So that's basically what this chart is all about. It's either caching the information here, or not caching the information. All right. So this survey, I still don't remember what service this is, because it's hard for me sometimes to remember the icon, right? CloudFront is right here, but I don't. If you guys, any of you know,
DynamoDB?
no.
No, it's not.
DynamoDB, it's DynamoDB. Let me see, one moment.
Elastic load balancing.
Elastic Load Balancer?
Yep.
Okay. So that's in front of the, makes sense, in front of the EC2 instances. I still have to take a look at this. That sometimes I haven't even cared about the icons. I know the most common ones. This one is very easy to understand. It's just a bucket, right? But there are some of them that are really weird, and the shape that they have is weird. I don't know why they came out with this. This doesn't make any sense. It doesn't. I don't know. How can you determine this is elastic load balancer? You just have to memorize this as the 4 squares here, and then 3 more squares that are big. Okay. Okay, so here it is, elastic load balancer, right? It's right here. Okay, so you have the user, and the user is using this guy here. Okay, and he's also using Amazon Route 53 because this is global. This is a global service, right? And so this is easy for you guys. I mean, this is easy to understand, this architecture here. I think that we've seen this many times, and it doesn't change, right? Something like this we're gonna build on Wednesday probably, right? Something like this, okay? We're not gonna use these guys like Amazon Route 53 or CloudFront, because that incurs money, incurs charges that we're not willing to pay, okay? So this is at a more, at a more global level. And believe me, creating a distribution of CloudFront will take hours to provision, probably talking about probably 24 hours to provision, and it's gonna cost, okay? So we have, this is some information here. We have a VPC here. We have some availability zones, right? And we have 2 availability zones, and then we have like 3 backend apps here. And then we have like a cache location here with Elastic Cache. Elastic Cache is a service that is used with RDS, right? To cache the information with RDS. For Amazon S3, it's CloudFront, okay? And for RDS, it's Elastic Cache, okay? Very important. If you want to cache the information for your database, this is the guy. If you want to cache your information for your DynamoDB, then you use a DynamoDB Accelerator. That's another service for caching. Okay, so every service has its own caching, strategy, right? Feature. Okay. How to enable CloudFront? So we have the developer here. You create a distribution, right? And then it begins to work with edge locations right here, right? To cache the information. And then we have Amazon CloudFront. And then when the customer gets to the edge location, then it will distribute the information. And then using this URL here, the customer receives the information, right? And also when the customer uploads the file in S3 bucket, right? As well. So you upload the file and then you get the file from the S3, okay? Now for that, he's using that. Now, when you create a CloudFront distribution, okay, we can put here CloudFront. You have to create a distribution here, okay? So this is a way, if you're gonna have a website or something like that, like distribute, web content, and also like HTML, CSS, PHP, all the graphic and different languages for websites, right? Probably React, Redux, JavaScript, PHP, all those guys, the JS. So you can create a distribution here and the viewer protocol policy, right? It can be this, it can be redirect HTTP. So what CloudFront has is that if someone comes with HTTP, you can redirect it to HTTPS, right? Or you can accept HTTPS only. So setting this value would drop any HTTP traffic, okay? So it would not allow any traffic to be HTTP. So if you wish to redirect, you can do this, right? And then whatever comes with HTTP, then it will redirect it to HTTPS, right? Yes. If you want to CloudFront to allow viewers to access your web content using HTTP or HTTPS, specify HTTP and HTTPS. If you want CloudFront to redirect all HTTP requests to HTTPS, specify redirect HTTP to HTTPS. If you want CloudFront to require HTTPS only, then you specify that. Okay. So basically these two are very similar, okay? But in this case, you're getting HTTP, okay? And then you redirect it to this one. Where is it? Here. That's the viewer protocol policy. Okay? Allow HTTP methods. The other methods that you can allow. You can allow the get head options, put, post, patch, delete. Okay, so you can allow all these guys here. Now, if you click here, select the list of HTTP methods you want to allow for the cache behavior, for this cache behavior. Okay. If you want to know more about HTTP methods, then you can Google them. They're pretty easy to understand, but not difficult. Okay. So the default TTL here it's just this. Okay. You can calculate this. This is in seconds. You see how many hours they're going to be there. Okay, so you can customize that, right? You can use the default one and keep it that way, right? And this is the maximum TTL, this is the minimum, and the default is this one, right? So you can go from 0 all the way from 0 to this. Let's say that you want to keep it, let's say, maybe 3 or 5 hours. That will be something like this, right? Right. Yes, something like this. Right. So I know this is 3 or 5 minutes. It will be 5 hours, right? Something like that. Like 60 minutes per 5 multiplied by 5. Right. So maybe you want to, you want to keep it there maximum, or maybe you want to change. I don't know. Maybe you want to do it. I think you want to do it here. Okay. All right. So that's how long that's going to be there cached. Okay. Maybe you want to forward the cookies, smooth streaming, more advanced. Maybe you want to have some WAF. This is web application firewall. You want to make some more security here. This a little more security. Okay. The price class, use all edge location best performance. Maybe you want to use some edge locations in Canada, Europe, Asia, Middle East, and Africa, right? Or maybe you want to use all edge locations best performance, or only Canada, US, and Europe. Maybe you want to use another domain instead of use the one that CloudFront provides you with a DNS, just like load balancer. But probably you want to use a specific customized one. Okay. And then you have many other, other features here that you can enable. Logging, just in case you want to log, and what bucket you want to put it for in. So as you can see, S3 bucket is the guy for logging to store the logs, right? So you can choose here what of all my S3 buckets, which one is the one that I want to store the logs in. Okay. Maybe if I have a prefix, like, so like a specific folder, like something like that or something. Okay. Maybe I want to log the cookies. Okay. And here, if I want to enable IPv6, okay. Maybe I don't want to get only IPv4, because this is a regular IPv4 IP address, right? But IPv6 is 128 bits, right? It's a hexadecimal address with 128 bits, okay? So this is the future, guys. That's the future, because last time I checked, we were running out of this IPv4 addresses. Is there any question in the chat? That I see that the chat is flashing constantly? Guys, you can ask me if you want to. Some communication here. Good. So let's continue. Any other questions? So this guy is pricey. Okay. You can even import a certificate here using the Amazon Certificate Manager. Okay, that's another service that Amazon has. Okay, the Certificate Manager, AWS Certificate Manager. Okay, so you can put your, let's say here, I want to have my certificate here, my classroom site. Okay, that's it. Then I can go next. DNS validation. They want to make sure that that domain is mine, right? And then I can have some tag, review, and then this is something that you can do as well with AWS Certificate Manager, right? That's another service that you guys can use for certificates, right? So CloudFront enablement options. Use a separate CNAME for static content. So you should have two CNAMEs, one for static content and one for dynamic content. It's very important to have this just for, this is for high availability, right? Just in case you have to reroute to the static content, your website is down, and you still want to offer content to your customers, it's good to have another CNA, right? So static content cached, dynamic content straight from the origin. What is the origin? S3, okay? It's where you have your static assets, right? It's most efficient, more effort to set up and manage. Of course, you have to set it up, you know. So point entire URL to CloudFront, easiest to manage. Use URL patterns to stage dynamic content. All content goes through edge locations, okay? So this is something that, guys, you need to consider when you're using in CloudFront, right? So you can use this and this, okay? This has a lot of efforts, but it's most efficient, right? This one is easy to manage, but still is a good, option to keep your assets being delivered efficiently. So CloudFront distribution, so you have here, DNS. Guys, when it has to do with world content, world users, global delivery, this guy is gonna be there. Okay. Route 53, as you can see, it looks like like a wooden man, something like that, And what it does is it's just routes the traffic based on the policy that was chosen. Okay, based on the policy that was chosen. Okay. So I'd like to give you a demonstration how to use the geo-proximity routing, because I have a VPN service, and I can connect to different countries. I can connect from here. I can have an IP address in Brazil, for example, and I can create several EC2 instances. I can create one EC2 instance in Paris, one EC2 instance in Singapore, and one EC2 instance in Sao Paulo. So I'm just let Route 53 do his job. And if I am connected to, and I change my IP address to Brazil, guess what EC2 instance is going to be closer to me? The one in Brazil, right? So I wish I have some time to, I think probably I might have time to give you a demonstration how to create a routing policy with Route 53 and then route the traffic based on location, my location. Okay. So we have here the sample.com. Remember, the Route 53 is a DNS service. And what it does is translates that domain into an IP address, right? Because the machine, like you already know, the machine doesn't understand www.example.com. What it understands is an IP address, right? So you make this request to CloudFront, and that CloudFront tells the distribution that you create, right? It tells CloudFront where your objects are. So your objects are going to be here probably in this Amazon S3 bucket, right? And the time to live is 36. That will be 6 hours, right? 6 hours. And then you have several files here. Whenever you use a wildcard, this is a wildcard. What it means is that every file that has an extension JAP, give it to me, okay? Or every file that has an extension as JS, JavaScript, or PDF, or HTML, etc. So this is just a replacement. It's a wildcard that tells me that whatever is before this point, this dot here, I want it, okay? That's what I'm looking for, or that's what you have, right? Here, the origin is, it's an elastic load balancer, right? And then the time to live is 0. This is not a caching thing, right? So download distributions to access your web content. Streaming distribution deliver digital media using Adobe Flash Media Server and the real-time messaging protocol. This is RTMP. When you create a distribution, let me go back to CloudFront. You have the two options. You have web, right? Or you have RTMP, which is what? Real-time messaging protocol. Okay, so create a real-time messaging protocol distribution to speed up distribution of your streaming media files using Adobe Flash Media Server's RTMP protocol. An RTMP distribution allows an end user to begin playing a media file before the file has finished downloading from a CloudFront edge location. Note the following. To create an RTMP distribution, you must store the media files in an Amazon S3 bucket, and to use Amazon CloudFront live streaming, create a web distribution. So this is for media files in Amazon S3, and for live streaming, you create a web distribution right here. Okay. Use live streaming to stream an event in real time. So even for this that we're doing here with Zoom, that we're streaming the class, okay, this can be done here with CloudFront as well. And all your videos are gonna be stored in an Amazon S3 bucket. So it's pretty good. Amazon CloudFront is very, very super useful, okay? But like I said before, it's expensive, okay? So CloudFront speeds up a website. We know that already, okay? We know that you can use cache control headers. Cache control headers set on your files identify static and dynamic content. You know, the header is something that always identifies things. So if you do a request, an HTTP request, right, to a specific API, always in the header, there's gonna be content, right? It's gonna be the content type. What are we asking, right? What are we asking? Asking a picture, something. So what are we asking for? What method are we using? Are we using get? Are we using post? Are we using delete? Are we using patch? Are we using put? I don't know. What are we trying to do? Sometimes the header also has the credentials, just in case I am accessing a specific resource. And for that resource, you need to have credentials. Okay. So the header always carries content. Okay. So you can set that in Amazon CloudFront as well. Okay. So you can identify if it is static, the content, or if it is dynamic. Right. So delivering all your content using a single Amazon CloudFront distribution helps to ensure performance optimization on your entire website. Don't forget that this is only if you need it, okay? CloudFront is not mandatory. It's only if you need it, if you're going global, if you want to, you know, offer your services to the entire world of most of the world or at a global level, then Amazon CloudFront can be very useful. But if you don't use it, you're gonna have some trouble, right? Because you are, you know, delivering content to the entire world, right? So that's something that you might consider if you are going global, you know, that type of global. So the expiration period is set by you. If your files don't change often, set a long expiration period. How long is a file kept at the edge location? Set expiration period by setting the cache control headers on your files in your origin, right? So the origin is, you know, it's your S3 bucket. So what you can do in S3 bucket is just have a policy for that, policy, a bucket policy. So the time to live, a fixed period of time, expiration period, right? Time period is set by you, right? It's set by me right here, right? You can use the default one like you said before and customize it. Or maybe you want to learn more about it, okay? Get request to origin from CloudFront, we use if modified since header. So this header is going to tell you if the file was modified or not, okay? But that's something that you have to, if you want to know more about headers and all that, then you can go ahead and search that probably. Um, right here. Okay. There's something you can do here. Custom header keys, values. Okay, the key and value is this key value. Okay, will be included in every request to this origin. If um, if the header was already supplied in the client request, it is overridden. Okay, so origin ID. This value lets you distinguish multiple origins. Is the same distribution from one another. Okay, so that's usually an Amazon S3 buckets right here. Okay, the origin is Amazon S3 bucket, right? And then you can have those custom headers here, right? If you did this in the origin already, this is gonna be what? Overridden, okay? Those are gonna be overridden from the origin. The origin is the S3 bucket. So change object name, for example, header dash v1 dash dot jpg becomes header to, new name forces refresh. So every time you change a name, that's a refresh, right? It forces a refresh of the entire thing because you're just using a different name, right? So the most preferred option are to use time to live and to change the object name. Using time to live is the easiest option if the replacement does not need to be immediate. Okay? If you set the time to live for a particular origin set to zero, server to zero, CloudFront will still cache the content for that origin server. It will then make a GET request with an if modified since header. This header allows the origin server to signal that CloudFront can continue to use the cache content if the content has not cached at the origin server. Okay? So it says here, changing the object name requires more effort, but its effects are immediate. Okay, so this is for immediate effects. This is if the effect is not immediate. You can set a time to live. Okay, you can invalidate the object. Okay, don't use this. This we use just in case, like the last resort, and it will be used sparingly for individual objects. Okay, so what it does is a bad solution because the system must forcibly interact with all edge locations. Okay. If you have several edge locations, they have the same cache information, right? So if you do this, it will force a change in all the edge locations. That's kind of, a bad solution here. So the best solutions are these two, right? This one is when the change has to be immediate, right? And this one is when, it's not immediate and you can take some time to just to update the information. Right? Storing web accessible content with NoSQL database. So when it comes to this, then we have this is DynamoDB. Okay, whenever you see NoSQL, that's DynamoDB. So we match the technology to the workload, not the other way around. Okay. So we don't match the workload to the technology, right? We do the technology to the workload. Okay. So we have to create all the architecture with the technology needed for that workload. Okay. So you can choose from an array of relational database engines, NoSQL solutions, data warehousing options, and search optimized data stores. Okay. I have a question for you guys. If I mention relational database engines, what comes to your mind? Can you tell me what comes to your mind?
Can you repeat the question?
If I asked you, tell me something about relational database engines in AWS, what can you tell me?
Can be Aurora, MySQL,
Correct. What else?
SQL Server, MariaDB,
What else?
MariaDB,
MySQL,
What else?
Postgres SQL,
Okay. Oracle. All right.
Oracle,
If I say data warehousing, what comes to your mind?
Redshift,
Redshift,
Good. And search optimized data stores? Search? Sounds like something like Elasticsearch. Okay. Right. Okay. So we have these technologies here that we can use for, just to cope with the workload, right? So database solutions considerations, read and write needs. Okay. So DynamoDB, right? DynamoDB. I don't know about you guys, but I love DynamoDB. So we have this guy here, and then if you don't use these default settings, what do we have here? What do we have here? Okay, so we have read capacity units and write capacity units. So this is a consideration that you guys have to know. And you have the capacity calculator here, right? It depends if you're using strongly consistent or eventually consistent, right? Eventually consistent, there's a delay in the write, right? There's a delay, and then whatever other replications you may have, the information is not going to be there immediately. Okay. Then strongly consistent is going to be the opposite, right? It's going to be there immediately, and transaction has to do with transactions. There's something different that we don't have to worry about that. You have to know this for sure for your developer exam. You have to know this. You have to be able to calculate this capacity here. Okay? This calculation that is doing this for you, you have to be able to do it with your mind. I mean, mentally. Okay? For the exam, for the developer. But it's not difficult. It's just, it's just a matter of getting used to that. It's not difficult. All right? But this is something that you have to consider when choosing a database, right? The read capacity needs, right? The total storage requirements. As you can see, this guy, when you create a table, you don't have to choose any storage capacity here. Why? Because this guy is highly scalable, okay? DynamoDB will adjust to any demand that happens. You don't have to start with any, you start with the capacity. You choose the capacity, the target utilization, minimum provision capacity, but you don't have to choose any gigabyte or, any storage, anything, okay? Typical object size and nature of access to this objects. So how big the object is going to be, right? Durability requirements. If you're requiring 11 nines, 9 nines, how durable the information needs to be for this particular, upload. Right? Latency requirements, how fast it is, the higher the capacity here, the faster it's going to be. But you see here, on demand, right? Why is this here? Wait. Here, provision. So, I have to delete my tables. I have like 3 tables there. Yeah. So as I have the free tier, it's kind of difficult to, choose this capacity because it only includes this guy, right? This 5.5, that's what is included in the, but if I click here, then I can change it, okay? So they suggest this, right? But if I just unclick it, then I can choose here. Look at the price, how it changes. You see? And then the price calculator is going to be here. Let's say that I want the size of, it's only 1. I want strongly consistent. And item read right second, maybe 5. Or maybe item right, right in 5. 291. If I choose 5.5, that's 291, right? That's exactly what we chose here. Okay, that's 291. But the more, let's say I want to go with 100, and this is 100. You see, and this is only one item. If I put 10, that's going to be even, it's going to be exactly the same as 1, but probably like 10 times more. Okay, so that's going to be your cost every month, right? For 10 items, I mean, items that are going to be, not 10 items, items are going to be 10 kilobytes, right? Which is not that big, but it's going to be that way, okay? So this is how you have to understand this. I mean, you don't have to know how to calculate it. There's like a formula that you can use, guys, to calculate this mentally and by yourself. But you just need to understand that when you considering choosing a database, especially DynamoDB, you have to be aware that this will change the price drastically. Okay, the read capacity units and the write capacity units. Okay. The nature of queries, so how the queries are going to be, right? What are we querying? We're querying the entire table, or we're querying just part of the table. Are we querying several tables? I don't know. The things that you can use. The maximum concurrent users to support, how many users are connected at the same time? How many users are requesting that information at the same time? If you take a look at the load balancer metrics, you're going to see that it has a metric of how many users are connected at the same time. Okay, requires strength of integrity controls. How the data will be consistent and intact, right? What securities you have in place to make that whatever control you have your database will be intact. That's very important. Security in AWS is not charged. It's free. So whatever encryption or whatever users access keys, all that's free, right? But this is something that you have to consider when selecting the database, how secure it is. So we have SQL databases versus no SQL databases. So we have relational databases here, no relational databases. So this guy is, all the information is stored in rows and columns, right? And in NoSQL, so we have this guy here, it's in key value, document, or graphs. So we have a key value here. If I just cancel this, and then I go to my first table, I have like maybe 4 items here. So maybe if I just bring this guy here and I put it in a text format, this is, the way it is in DynamoDB, right? That is a key value way, key value way, key value. This is a key value of a key, okay? We have a key here and the value is a pair of another key value. Okay, that's like a nested object. You know, the value is just the key pair of another key. Okay, so we have here a key whose value is another key, whose value is a key, whose value is a pair. So it's just a JSON format that needs to be understood. Okay, but this is easier, right? This is just a simple JSON, right? This is just DynamoDB for you to see how the database is structured, right? Okay. Rows and columns is, if you take a look at an Excel spreadsheet, you're gonna see rows and columns. And if you take a look at any table, you're gonna see rows and columns. So, and this guy breaks the pattern. It's just it's a crazy stuff that AWS came up with, and is so effective and so coveted and so popular right now. Right? The relational database, it has a fixed schema, right? So if you have like 4 columns, that's exactly what you have to, where the data is going to be, 4 columns, right? But with DynamoDB, it's a schema-less table. You can see here that, some items have an ID, they have an age, and then they have a name, right? Another item has an ID, has a computer, has a product, and doesn't have anything else. Another item has an age and has a product. You see? It's age and first name and last name. And another item has a name, an ID, and a product. So it's a schema-less and a wife name. It's a schema-less database, okay? It may be confusing at first, but once you get used to that, you see how fast and effective it is, okay? So it's a dynamic schema. It's not a fixed schema. With a relational database, you have to have this. And every column has to be, populated if it is required, if it is not null. If it is null, it can be empty. But it has to be, it's just a fixed. Imagine this as a relational database. We have to have values for every single column, okay? Because it's a fixed schema. With this database, it's not like that. You just create the item, right? And then the item, you can put whatever you want, okay? When I said whatever you want, I don't mean chaos, right? Not chaotic, not something that not even the owner understands it. I mean, it's flexible, okay? It is not restricted like a relational database, okay? So we have the querying, you can use SQL. And these guys, we have a collection of documents. We can use other technologies for that, like this guy here. Okay, you can use this guy here for bringing the database, from your DynamoDB. And this is the way it is. It's basically JSON too, right? This is your JSON, and then you can bring your items from here. All right. Okay. This is another technology that, guys, I suggest probably you take a look at. This is very popular right now. People are just, moving towards GraphQL because many companies are adopting the serverless architecture. And for serverless, use Amazon DynamoDB. Okay, so with Amazon DynamoDB, you cannot use SQL. Okay, not that language that we know, insert into table name, all that. No. DynamoDB has to use something like this, probably a document or like this. So this is an example of, your database, relational one, the ISBN, the title, author, format. You see, it's a fixed schema. Okay, and it scales vertically. Okay, vertically, right? So what you can do is increment the power of your database. You can increase your the family size, right? You know, if it is a DB.2 T2 micro, maybe you can use a DB.T3 micro or something like that, right? So what it does, it scales vertically, right? If you wanted to scale horizontally, then you have to create a read replica, right? A read replica. In this case, it scales horizontally and is automatic, right? And this is an example of a database that is NoSQL, right? As you can see, it's JSON, right? Key value, key value, key value, key value. Okay, that's what JSON is. So NoSQL databases can be an alternative to relational databases for some types of applications. Right? It's an alternative, but it's a very good alternative, right? It can process large amounts of data with high availability depending on the NoSQL solution, configuration, and architecture, right? So DynamoDB is not the only one in the world, right? We're just talking about NoSQL, DynamoDB, right? And this guy, it can work in under the 2 digits. It's a 1 digit millisecond of response, right? Super fast, super fast. One moment. And then it formed a broad category with different implementations of data models, features distributed fault tolerance. So this guy is super highly scalable and highly available. So that brings all of this, you know, all of these characteristics here, like fault tolerance and all that. NoSQL databases, does your application need transaction support, ACID, compliance, joins, and SQL? Then, you know, if you need transactions, ACID, all that, joins, all that. Can you respond? Can you answer this question, guys? I don't think I have to give you the answer. What database do you think that we can use there?
RDS.
RDS, right?
Yeah.
RDS.
Right, because we can use joins and we can use SQL, right? And we can use transactions, right? So does anyone know what this stands for? This stands for? I did it in my morning class, but probably I have students from a morning class here. Can anyone tell me what this stands for?
It was like autonomy, consistency, isolation, durable.
So if we're going with the nouns, then you say atomicity,
Yeah.
consistencies, isolation, and durability.
Oh, okay.
We're going with the adjectives: atomic, consistent, isolated, and durable.
Durable.
Okay. So these are the, you know, characteristics of any transaction in life, not only databases, in life. Any transaction that you make, whether a bank transaction or anything, they are ACID, right?
Complex transaction.
Huh?
Complex transaction too.
Yes. So another question is, can your application do without this for all some or part of this data model? Okay. Refactor database hotspots to NoSQL solutions. Can it do that? Can it offer increases in flexibility, availability, scalability, and performance? All right. So when you ask those questions, then the answer is you know, that, you know, if you don't need any of this, then you can use NoSQL databases. Okay? If you don't need to do any complex transactions or any joins of SQL or anything, then you can use a NoSQL database. So NoSQL in Amazon EC2, sorry, Cassandra, HBase, Redis, MongoDB, Couchbase, and Ryak. Okay, so these are some of the NoSQL databases on Amazon EC2, right? RDS supports 6, remember, right? 6, RDS supports 6 SQL databases. So we have these others that are NoSQL. This is very popular, okay? Redis, MongoDB is super popular. Now, Redis is for Lasti. So we have Redis here. Redis compatible in memory. So if Redis compatible, right? So we have these guys that is it's compatible with Redis, okay? But Redis is another. It's a third party, you know. It's an open source database, open source, right? It's just you know, it's a third party open source database. NoSQL database, of course, and so it has caching, all that, and the caching is it's with this guy here. Where is it? Where's the guy? Where did I put that? Okay. So this guy is the guy that works with the Redis, right? Elastic cache. It's used for your RDS, right? And it's in memory. Okay, it has a memory. It's just caches the information in memory. It's a data store, fully managed. Okay, and it has 2 flavors: Redis and memcached. Right? If you want to have for really heavy duty, you know, workloads, Redis is the guy. You know, memcached is just a little less, you know, powerful. Power real-time application with some millisecond latency. All right. So that's Redis. MongoDB is a very, I don't know if you have used MongoDB's guys. This is a very popular, super important when you have the MERN stack, for applications that are full stack. MERN stand for MongoDB, Express, React, and Node.js. So there's some architectures that have a MERN stack, and people use the full stack applications that use this database. I personally love MongoDB. I've worked with MongoDB, and it's easy. So you can create an Express server and then connect it to that. MongoDB is super easy. It's not difficult. Okay. Cassandra is another one. That's another one. So I'm gonna do, as you can see, Amazon AWS has a lot of integrations to you know, integrate with third-party services. Let's see. We have some plans here. Some dedicated virtual machines here. 3 for startup, 2, 3 for business, 6 to 30 for premium. You know, CPUs here. $265 per month for this little thing. Okay, because they charge you per hour. Right. That's another one. So these are examples of, you know, these guys, you can put them on EC2 instance. So if you have an EC2 instance, you can host these databases on the EC2 instance. This makes this less highly available, okay? So you have to create auto scaling for this, okay? Don't forget about that. So managed NoSQL, Amazon DynamoDB, Amazon Nectum. This is a graphic database, graphic, Nectum. Elastic Cache with Redis, we just saw it. And Amazon EMR supports HBase, Elastic MapReduce. Big data platform. Amazon is the industry leading cloud big data platform for processing vast amounts of data using open source tools like Apache Spark, Apache Hive, Apache HBase. This is what it is, right? That's the one that supports HBase here. Okay. And this is the one that we have Redis here that is supported by Elastic Cache. Right? Okay, guys, let's have a break now. Let's have a 10 minutes break. And I'll see you back at 2:49. Okay, guys, we're back. Okay, so sometimes you have to shifting the database functionality to an NoSQL database. So the question is, when will you use NoSQL over SQL? That's a good question. Okay, so in addition to using managed services like AWS, DynamoDB, other options include the leaderboards and scoring, rapid ingestion of clickstream or log data, temporary data needs such as shopping cart data, hot tables, metadata, or lookup tables. So those are things that you have to consider. And this, what it takes, this is, I mean, session data, all that takes a heavy duty database. All right. That's something that you might consider Amazon DynamoDB for. Okay. So for example, an Amazon, an AWS customer, Scopely, decided to move the game state information into DynamoDB when they exceeded the capacity of an Amazon RDS instance. So when they were using an RDS instance before, right? And they understood that whatever infrastructure they had was not enough. Okay, so they needed something more powerful and more efficient based on the amount of requests that we're getting in the database. So they could have used RDS sharding. Remember what we talked about sharding, how you can partition your database and have different shards. And when you have different shards, you're more highly available because your partitions are not gonna get hot. So if you have only one partition, then your database, you may not end up having a hot partition, and that's not what we want. So instead of doing that, what they decided was to go for a NoSQL database, and they chose DynamoDB because what they needed was to store game state information. So they wanted to have something really, really, really powerful that could help them deal with this massive wave of requests to their database. So they moved their game state info into DynamoDB when they maxed out an RDS instance. As a solution, they chose a NoSQL database to store the game state information, like I said before. Okay. So DynamoDB, fast NoSQL database service, making it cost-effective to store and retrieve data and serve any level of request traffic. Let me tell you something, guys. DynamoDB may look expensive at first, but in the long run, it's cheaper. At times, it's cheaper than RDS because you are giving users a better experience, a low latency, a single-digit millisecond performance. And that may ensure that you have more customers, you make more money, okay? So it's all about how the user feels after experiencing the performance of your services. That's all about, that's how the user is satisfied with your services, the level of satisfaction that your users have. Okay, so a benefit of this Amazon DynamoDB database is that it gives you low latency. That's super important. When it says single digit milliseconds, it's under 10, with 10 not included. Okay, because that when you include 10, it's already 2. A single digit millisecond. So the database is able to perform between 1 and 9 milliseconds. That's hugely fast. Okay, so companies, they use a lot of DynamoDB for their gaming and for mobile. Okay, the management console to scale up or down to meet your needs. Okay, and you can create DynamoDB deployments in minutes. So these are the main benefits of DynamoDB. Okay, So DynamoDB tables, there's no fixed schema. Just, you know, circling back to the same information. No fixed schema. And each can have different attributes. Performance, reliability, and security are built in, so you don't have to worry about that. Okay, with RDS, if you want to improve the performance, can you give me the answer? What do I need to do? What should I do if I want to improve the performance of my RDS database? Please, can you answer that? Can anyone give me that answer? If I want to improve the performance of my RDS, what should I do?
Automation.
Oh,
Do you pick a bigger instance type?
what if that one goes down?
You have auto scaling? Oh, sorry, not auto scaling.
Starts with R.
I mean, it's just redundancy. You just
But what do I need to do? What should I do? Create what?
Replicate.
Correct. Read replicas. That's what improves the performance of my RDS. What improves my availability? The availability of my RDS.
Deploying it in multiple availability zones.
Good. Multi-AZ. Okay. So multiple AZ or multi-AZ feature, you enable it for high availability. And you create read replicas for better performance. Okay. None of this needs to be done with DynamoDB. Okay. DynamoDB is natively high performing and highly available. Okay. So the key characteristics of Amazon DynamoDB: predictable performance, provision throughput model, okay, durable and available, consistent disk only writes, on demand, backups, okay, on demand. So if you need it, you do backups. You don't need it, you don't do backups. Fully managed NoSQL database service, zero administration, zero. With RDS, you have to configure it. Remember, RDS is managed, not fully managed. Okay. So I guess that these are the key characteristics of DynamoDB. So DynamoDB data model. Okay, so we have data partition by the partition hash key. So we have the hash key here. So every single, every single item has a key, right? We have the usually, like I've said before several times, usually the partition key is just a unique number, like an ID. And the sort key, which is a range, is usually like a timestamp, like, like an alphabetical thing or chronological thing. And that's the way that you can find items real quick. Okay, so the data store elements store as attributes, right? Attributes here. And you have items. This is an item, right? A table is a collection of data elements, okay? And we have the sort key here and the partition key here. So the partition key is what we call the hash key, okay? And the sort key is what is called the range key. So there are different ways to name that or to call it, okay? But basically, this is what DynamoDB looks like. You already saw it in the console, right? I show it to you, but this is like a graphic, like a chart for you to see each element one by one, okay? But basically what we create in DynamoDB is items, right? We create items. So we have here a user table, users table, attribute string, binary, number, string set, etc. We choose the type of the attribute, okay? We have on the table here friends table, right? So we have a composite primary key. It's formed by two different keys. We have the partition key, the sort key, and the partition plus sort is the primary key. Okay. In this case, we have just a primary key. Okay. Okay. Primary key, we have this, Bob, the nickname is Bobby, and the nickname for Alice is Ali, and then Caroline, Carol. Okay, so we have here, you know, the table for a users table, right? And we simply have one primary key, is the partition key, right? We don't have a sort key here, but in this case, we have a partition key and a sort key here. All right. So query for Alice returns friends. Okay. So what is a friend for Alice? Terrence. What is a friend for Alice? We have Sarah. James. A friend for Bob. We have James here. Okay, so Bob is a friend of, James is a friend of Bob's and a friend of Alice's. Okay. So Amazon DynamoDB consistency. DynamoDB synchronously replicates that
Oh,
across.
sorry.
Yes, go ahead.
Can you go back to the? I don't understand how Bob James came to this. If the
Oh,
query is for Alice.
you have to create a query.
Yeah, but
You have to query. It's just the way you structure your.
oh, this is the information. This is the data.
Oh, yes. This is not the table. This
Oh, sorry. I thought this was a query that you have done against Alice.
No.
Friends. And I said, where does Bob fall into this whole picture?
Yeah.
Never mind. I got it.
Yeah, you create a query and then return the friends for Bob or the friends for Alice. Okay. So DynamoDB synchronously replicates that across 3 facilities within an AWS region. Okay, that's synchronously. It means almost at the same time. Okay, it's just replicating 3 different facilities, availability zones here. When it says facilities, it's availability zones. Okay. And you can specify at the time of the read request whether a read should be eventually or strongly consistent. If you want it to be, you know, real, you can see the information immediately if it is strongly, or if you just don't want to see, you know, just decide not to see it immediately. But remember, the cost is going to be influenced by this, right? It's just how fast your information, you want your information to be available. Okay, this is going to influence the cost. Don't forget that. When we create the table, the DynamoDB table, if you create a new table, when you choose these guys, right? If it is eventually consistent, for example, let's say that I wanted 5 and 6. You see how it affects the price? So this is $339 a month, and eventual consistency is going to be $320. Because this guy takes more time for the information to be available. That's why it's going to be cheaper. but this one is going to be more expensive because the information is going to be almost immediately after it's been, written. Okay, so that's affects the price. That affects the price. Okay. Global tables. So we have here. I think that. Let me see here. Let me go back to. Let me cancel this and go back to one of the tables. I can have here the tables, and if I choose this guy here, I can have the global tables here. Okay. So if I want to replicate this table in a different region, right? I can just add the region. You have to enable it. I enabled it already. There should be a button here in your account that says enable add region or something. So you add the region and then you select the region here. You can just maybe you want to see it and you want to have it in let's say in Tokyo. Okay. This might not work because my account is it's the free tier, as you can see. Right, capacity should either be paid per request or auto scale. Okay, so that's not possible with this account. Okay. So capacity here, on demand, probably here. Billing notification changing the setting will change how DynamoDB calculation bill. I don't want to be charged, so let me keep it this way. Okay. But bottom line is that you can have a global table, right? And you have here the main table, and then you can have several replicas here in different regions, right? So you have one in US West 2, you have one in US East 1, and you have one in EU Center 1. So you can have different tables here, right? To be more highly available in different regions, right? Remember that by default, it replicates your data in 3 availability zones, right? But this is something that has to be enabled if you want to have your tables in the world, entire world. You can replicate different tables in different regions here. It's going to be more expensive. Don't forget that. But that's going to guarantee that your tables are, deployed in regions, and then it's going to be more highly available. Okay. So once you enable that, DynamoDB will perform all the necessary tasks to create identical tables in these regions and propagate ongoing data changes to all of them. Okay. So whenever there is a change in the master, all the replicas will get that change too. So we have table 1. We have DynamoDB stream. That's something that I think I mentioned this guy before. That's for caching the information. DynamoDB accelerator is right here, in-memory caching service for DynamoDB. Don't forget that edge locations, CloudFront, Elastic Cache, RDS, and DynamoDB accelerator, okay, for caching information. It tells you here how it's functioning right now. This is taken from the health dashboard. It's telling you that the service is operating normally in North Virginia, which is the region that I chose here. Okay? That's the region that I'm in. Okay. So Dynamo Streams is something that is used for dealing with information. So this post describes some common use cases you might encounter along with their design options and solutions when migrating data from relational database stores to Amazon DynamoDB. We will consider how to manage the following scenario, how you set up all that. Okay, let me go down here and read this. you can use DynamoDB streams to address all these use cases. DynamoDB streams is a powerful service that you can combine with other AWS services to solve many similar problems. When enabled, DynamoDB streams captures a time order sequence of item level modifications in a DynamoDB table and durably stores the information for up to 24 hours. So applications can access a series of stream records which contain an item change from a DynamoDB stream in near real time. Okay, so whenever there's a change to one of your items in a DynamoDB, that's going to be recorded here. Okay, it's going to be recorded in the Dynamo streams. You can see that record here that was changed. For example, here we had this user thing here, right? User AAA, note ID, notes. So we added one more file here, one more element, one more item, AAA45B by milk. And then that change is going to be recorded in the DynamoDB stream, and it's going to be replicated in table 3. In table 3, or that's the 3, not that table 3, I'm sorry. That's the third step, right? So you have the first step here, this table here. Second step is recording the DynamoDB stream, and it's replicated in these 2 tables. Okay, and EU Central 1 and US West 2. Okay, so this is where the master data table is, database is. Right. So whenever you hear this guy, this is the guy that contains all the records of all the changes that have been made in a DynamoDB table. Okay, DynamoDB streams. Of course, you know, there's some CloudWatch and probably some S3 buckets involved somehow. Okay, they're gonna be there for 24 hours. Okay, but if you want to make that more durable, then you can find a way to store them in an S3 bucket and make it more persistent there. Any questions in the chat? That I see the chat is moving. I need to jump, Stanley. Okay, Stanley, don't forget to study. Okay, very important. Okay, so we continue. So the table that is identified as a global table. So we have US East 1. The writes and reads will always be strongly consistent. However, in the US Central 1, which is a replica, will only be eventually consistent for writes. Okay, so whenever write is, you know, in US Central 1, then that's gonna have some delayed. Okay, so for this one, we're gonna have some strongly consistent writes here. Okay, but this one is a replica, right? So it's gonna be eventually consistent. Okay, don't forget, when you hear this, there's delay in the availability of the data. When they're strongly consistent, it's right after it's written, it's right there. Okay, very important. So here, where there's a conflict can arise if the application update the same item in different regions at about the same time. So in this example, one user writes at 11:21 p.m. and a second writer, well, 11:21 with 3 seconds p.m. and a second user writes to that exact same item at 11:21 with 4 seconds p.m. To ensure eventual consistency and settle any conflict, DynamoDB global tables use a last write wins reconciliation between concurrent updates, where DynamoDB makes the best effort to determine the last writer. With this conflict resolution mechanism, all of the replicas will agree on the latest update and converge toward a state in which all the data is the same. Okay, so it's going to use a last write mechanism. So every data, all the tables are consistent when it comes to the data. Okay, so this is a conflict that DynamoDB can resolve real quick. Okay, that's another benefit of DynamoDB. it means that the last write wins. Okay. So DynamoDB can be created in 3 steps. Global tables, create DynamoDB table with streams enabled, and repeat first step for other regions and define a global table based on tables just created. Okay. So first you create an ordinary the DynamoDB table with DynamoDB streams enabled. Let me see if I can do that here. So I think that I can come here to that dashboard, create a table, and then so probably if I come to the table, I go here minus stream and they say they're enabled already. You shouldn't want to share this. Okay, this is enabled already. Okay. And then you do the second step that it's right here, you add the region. Okay. So when you create the table, you enable, once you create it, you enable here. Enable streams. There you go. The stream is enabled, right? And then you can create the region. So to be able to have this button clickable, you have to enable the streams. Okay. That's the first step, right? The table with streams enabled, right? And then you can repeat the same process for all the regions. So you can create this, add the region, and then do one region, do the another region, and then that table is going to have global tables in different regions, which are replicas of that master table. So Amazon DynamoDB best practices, you keep an item size small. It's very important to have, to be, keep it simple. Okay. So what do you store in DynamoDB? Metadata. Okay. Data about the data, right? And in large blobs in Amazon S3. Okay. So you can have these blobs here in Amazon S3. Normally, what do you store in DynamoDB? The name, first name, last name. But if a person has, for example, the person has a picture, let's say that your website is a profile, right? The person updates, uploads information about profile, right? So what you do, you store, right? You store your metadata in Amazon DynamoDB, and whatever assets that come with information, that you store them in an Amazon S3. Okay, so Amazon AWS object storage comes in form Amazon S3 or simple storage service, and Azure object stores is available with Azure blob storage. Oh, by the way, if you want to go for an Azure AWS, not AWS, Microsoft Azure certification, the fundamentals, it is exactly the same as Amazon AWS. It's exactly the only thing that changes is the names. They also have an S3, not S3. They have a container, like a bucket storage. They have something similar to DynamoDB. They have something similar to Lambda. Everything is like a copy, guys.
A couple of years back when they have Steve Ballmer, Steve Ballmer used to say that Linux was the devil. Yeah. And now Microsoft is moving to Linux, to their own I find that so interesting.
Yeah, if I didn't read wrong, there's some people that are preferring Microsoft Linux over Microsoft right now.
Yep, a lot of people.
Yeah.
A lot of companies.
When I got my certification in Amazon Azure, guys, it looked to me like Microsoft copied everything from AWS. I was in shock. It is almost the same thing, different names, almost the same. They have I am users, but they don't call it I am users. They have a different name. I think that's the strategy they use to not to get any copyright thing. They change the names of the things, but basically it's the same thing. I was amazed. Okay, and blob is what Microsoft Azure calls an object. Okay, so objects, you put them in Amazon S3. Okay, like pictures, like files, videos, all that, and metadata you put in DynamoDB. Okay, use a table per day, per week, month. Okay, for storing data about time series. Okay, it's good to have some time series there, some timestamps for that. Okay, use conditional or optimistic concurrency controls updates. Optimistic concurrency control, that's something that Amazon has, and like you see, we say optimistic is, you know, it's something positive, right? So optimist locking with version number. Optimist locking is a strategy to ensure that this client-side item that you are uploading, updating, or deleting is the same as the item in Amazon DynamoDB. If you use this strategy, your database rights are protected from being overwritten by the rights of others and vice versa. So this happens when some people try to change the item at the same time. Okay, so it has optimistic locking. It means that it's only one change, no more than that. Okay, kind of confusing this particular naming strategy here, but you know, that's the way it is, and that's something that they have in AWS, because there might be some people trying to change the same item at the same time. So they thought about everything, and probably they had to run into issues first, because sometimes people don't change things until they run into issues, because they never thought that they would run into issues until they do, right? Avoid hotkeys and hot partitions. You know, when you have one partition that's getting a lot of requests, that could become a hot partition. So you have to have several partitions for that to be able to do that. You can create a secondary index or a global index, something like that, but that's more for your developer certification. Storing relational data in Amazon RDS. We're getting to something easier now. This is easier than DynamoDB because we're more familiar with this than DynamoDB, right? This is the guy that we most commonly know about. Okay, so if you're in the morning class, we're going over the same thing, right? This happens if you are on-premise, you know, on premises. You have to deal with everything. You have to optimize your application, scale it, make it highly available. You have to back up your database. You have to, the database, do some patches to the software, install the software, patch the OS, install the OS, maintain the server. You have to do some racking and stacking. You have to power. This is this is AC, and this is ventilation and heating and ventilation, AC. Okay. Now, if you go to the, you know, if you host it in Amazon EC2, I'm sorry. If you host it there, then you have to do all this stuff, right? You have to optimize the application scaling, all this, and AWS would do all this, right? But this is only if you choose the EC2, an EC2 instance to host your database. Now, what happens when you choose RDS is a different ball game. You only have to optimize your application. You have to make the code better. go more efficient, and all of that. And then AWS will take care of the rest. So you see the difference here? That's a huge
So-
difference. Yes, go ahead.
Can you stay here for a moment? You remember we had a discussion this morning about OS patches?
Mhm.
Brian, are you still there?
Yes.
Do you
It's
see
just-
it here on this chart? So your comments were correct as long as your database, it's running on an EC2 instance.
Yes.
So, okay.
Yeah,
Yeah.
no, sorry. It's just like I'm like juggling between this and helping my brother move something in the back.
Yeah,
Oh.
this is an Amazon EC2 instance. This is a server. So you have to do all the patching and all that.
No, yeah, but remember when we're doing the test this morning, the practice test?
Did you get that question right or not?
No, we got it correctly because it was not always patches.
Yeah, I
It was
remember we
really-
talked about the question, and some of Brian was leaning towards patches.
Yeah, I thought it was more patches because that is the responsibility of the customer.
Yep.
But
Like-
it's only in this instance where you own the database. Basically, you're hosting it on an
Yeah.
EC2 instance, but you still own the entire environment for that database.
Yes, I mean I understood that when I was saying it. It's just more of like, okay, so the EC2 instance is your responsibility, right? But everything
Uh-huh.
outside of that, no. Like the thing that hosts it, right? Like, so like if you get your own dedicated rack, right, that's your responsibility at that point, right? To some degree. But what I was kind of like pushing more was that the patching of the EC2 instance, right? So like, let's say you give you a Linux version, right? And you don't update it for like 5 years, right? That's your responsibility. Something happens.
Mhm.
You can't go to AWS and be like, why didn't you patch? It's like, well, it's your responsibility.
Correct.
And I mean, we still got the question wrong. I don't think it was patching. I think it was like,
No, we got it correct. We did get it correct.
did we?
So
Yeah, we did. We did get it correct.
Oh, okay.
whenever you have an EC2 instance, EC2 instance is not a fully managed, it's not a managed service. It's just you have to do the installations, you have to install the servers, you have to patch it, you have to do all that, right? You have to.
I guess the reason why I was bringing it up is Brian was saying that you are responsible for the OS patches. And I said, why would it be your responsibility if you're basically renting this environment and they're saying that they're responsible for maintaining everything, right? They're providing the technical, all the technical background to be able to maintain it. Now I see why
Well, like, okay.
why you are responsible for the OS patches.
Like, okay, so I guess I'll add a little bit to it. I wasn't going to, but when it comes to patches, right, you sometimes need to restart the server, right?
Uh-huh.
AWS doesn't want to be responsible for that because they don't want to restart your servers while you're using them, right? So they give you the responsibility of like, you'll patch it, you'll reset it, you'll restart it when necessary, right? You'll maybe create like another instance to kind of like switch while the main one, patches and reboots or to whatever degree, right? But that's kind of the reason why it's your responsibility because it's on your time when it has to be patched. Like there's servers that are never patched for like 5 years from what, like from like scary, secrets I've been told, right? So that's kind of like, it's the mindset of that. Like it's your security, right? So it's your responsibility to patch. That's it.
All right.
Thank you.
Now, if you hosted
No,
it,
the chart just brought it to light, like why was he saying that? Now I understand it.
so now if you hosted it on RDS, you only have to optimize your database by just making it more structured, make it easier to query, things like that, optimize it. But the rest of that, whatever is behind that, all the things that have to do with the below the hypervisor is taken care of by AWS. All right. So RDS optimizes developer productivity. It's just gives the developer the opportunity, developers to construct the queries in a better way and optimize the query. So you can innovate more than anything, because if it is taken care of by AWS, then what you can do is just do something better. And that construction of queries and optimization of queries is just what this application optimization is all about. Okay. So offload the operational burdens, migration, backup and recovery, patching, software upgrades, frequent server upgrades, hardware crash. This is all taken care of by AWS, all of this when you decide to go with this this way here, this option here, right? So now control Amazon RDS instances via security groups. We know that already. I think that you guys have done some labs about that, and it's a good thing that I have some of my students in the morning are in my afternoon. That's pretty good, right? Because sometimes one class complements the other. Not only the content that is taught during the class, but also in the labs. Okay. So encrypted instances are currently available for all database engines supported in Amazon RDS. The 6 database engines that are supported. Use AWS Identity Access Managers IAM to control which Amazon RDS operations each individual user has permission to call. Okay, this is something that you can limit a specific user to. You can encrypt connections between your application and your DB instance using SSL or TLS. Transparent data encryption, DTD, is supported for SQS Server and Oracle. This is another type of encryption that it's for third-party database engines. But out of the 6 that RDS supports, the only ones that have TDE is SQS Server and Oracle. So what this is, so transparent data encryption encrypts SQL Server, Azure SQL Database, Azure Synapse Analytical Warehouse. This encryption is known as encrypting data at rest. So data at rest is like we do with S3, right? That we can enable server-side encryption. The only one that has that with AWS is supported by AWS TDE. It's SQL Server and Oracle. The other ones, you have to find some workarounds for that. Okay. So you can receive notification of important events that can occur on your Amazon RDS instance. So notification, when you talk about notification, that's what service is that? What service is that? So what service is the one that gives notifications to users and subscribers?
SNE.
SNS.
SNS.
Okay, so we have Aurora. Aurora is a relational database delivery using service-oriented architecture. Don't forget SOA, service-oriented architecture, have to do with microservices. Similar to how Amazon DynamoDB is a managed version of an Amazon EC2 hosted NoSQL engine. Okay, so this guy is proprietary of Amazon. Okay, it's just similar to Amazon and DynamoDB is just managed. All right, it's scalable, highly available, and it uses Amazon S3. Okay, how many copies are automatically created for you when you create an Aurora database?
Is it 2, 3?
Oh. Morning class, last Friday.
I think it was 3 times.
I'm sorry, what's the question? How many
copies are created for you guys when you create an Aurora database?
6.
Exactly.
6. That's right.
2 in every availability zones, 3 availability zones, 2
So
copies,
it's 3 availability zones, 6 replicas,
2 copies in each.
2
Okay.
copies in each.
Okay, and it can go up to 15 copies. Okay, it's 3 times faster SQL and 3 times faster than Postgres. Okay, it's super fast. Dropping compatible with MySQL 5.6. Okay, Amazon RDS MySQL, because customers can select options for migration. It has a migration options for that. Amazon EC2 or on-premises, MySQL users can import the database files using the database migration, right? Services. And it's compatible with PostgreSQL. With SQL, we know that already. Because PostgreSQL is one of the database engines that Aurora uses. Not Aurora, RDS uses. And of course, Aurora is a SQL database, so you can use MySQL there, okay? So it's compatible with SQL and Postgres. It's integrated with Amazon S3 for continuous backups. So it is continuously backing up your data in an S3 bucket. So it creates 6 copies replicated across 3 availability zones, moves logging and storage layer into multi-tenant scalable service layers, multi-tenant. So it has a shared and multi-tenants. Let me see here. Okay. Amazon Aurora is also powered by solid state drive data planes up to 64 terabytes per volume. So it uses SSD. Okay. So you can see how fast it is. Now, this is very, very expensive. Okay. Aurora is for high-end companies. Okay. You see how available it is. You can notice how scalable it is and the capacity that it has. It's super fast, right? You pay only for consume amount, okay? Like, it just complies with the pricing model of AWS. You pay for what you use, right? Added in 10 gigabytes increments. So if we want to increase the capacity of an Aurora database, and you want to increase the capacity, it increments by 10, okay? It's not 7, 6, choose, one by one. No, it's just by 10. Just go 10, 20, 30, 40. That's the way it is. Right. It has a 4.9% available. It is 4.9% available. So as you can see, S3 is more durable and more available than Aurora. But S3 is not a database. So it has instance crash recovery. Compares, it's self-healing. It recovers real quick. It is, if you compare it with traditional databases that that replay all logs over single threads, this guy can do it over multiple threads, right? Aurora replace redo records as part of a disk read. So usually when there's a read in Aurora, what it does, it backs it up, okay? It backs it up automatically. So it means that it's constantly backing up your database. So it's continuous backing up your data. That has to be paid. It has to be paid for. That's something incredible this database has, okay? So you don't have to worry about any backups, right? Because every time there's a write, there's a backup, okay? So that's super good, okay? It has distributed asynchronous recovery, parallel, it works with different replicas asynchronously, okay? Guys, do you have an idea what's what's if I change the slide? Do you have an idea how long does it take to replicate?
I believe it's like 60 seconds, right?
10 milliseconds.
Jesus.
So all the database, they have like seconds or minutes. Our database has 10 milliseconds with replicate lag. That's what it takes. 10 milliseconds. Can you imagine that? How fast that is? Okay. So the cache layer survives the database restarts or whatever. Whenever you restart the database, the cache information doesn't go away. What happens when you restart your computer? Do you lose what is cached in the RAM memory?
Yeah,
Of course.
Look at this. Look at this guy.
that's crazy.
Look at this guy. It can survive any restart of the database, improving the read response. Of course, if my data is always available, even if I restart my database, that improves the read response, of course. Read replicas designed for instance promotion, up to 15 replicas. As you can see, Aurora is much more excellent than RDS, any other database that RDS supports, okay? But guys, you have to pay for that, right? So the
So
lab,
would you say that Aurora is the answer of Amazon for Microsoft SQL Server and Oracle?
what do you mean? Like
From a competitive analysis standpoint?
Well, it depends on what Amazon, Microsoft has, because Aurora is not the only database that Amazon has. I mean, Aurora is
go ahead.
okay. I still don't understand your question, but I don't know much about.
So it seems like Aurora, it's an Amazon specific or proprietary, right?
SQL.
Way of implementing
Mhm.
a SQL database. Is that correct or not?
Yes.
Okay. So if that's the case, they're trying to compete with Microsoft and all the other types of Microsoft databases. I mean, SQL databases out there.
This is
what's the use case?
This relationship between AWS and Microsoft is a little awkward.
I know.
It's a little weird because I'm competing with you, but still you give me a platform so I can host your databases. So because RDS supports Oracle and it supports my server. And you see that bittersweet relationship where we compete, but at the same time, I can support your databases.
So RDS is like, okay, I can support these other companies. So I'm basically like a partnership, let's say. I'm not gonna, that's the wrong word, but kind of like a relationship, let's put it that way.
I don't know.
And then you have Aurora, which actually competes with what these other vendors are providing.
I'm not sure about Microsoft databases, proprietary of them. I'm not sure, but I believe that if there's one proprietary, there should be the competition of Aurora. But I don't know how these deals are made. I don't know if for Amazon to use SQL servers that need permission, or I just create my platform that supports whatever database is brought into it. I'm not sure if they have to get to an agreement between the two of them, or simply Amazon created the platform and that was it. I support whatever comes from the outside world. I'm not sure. I don't know how this relationship works between the two of them, but they're for sure they're competitors in every aspect of that it has to do with the cloud. They're competitors. Okay, Amazon gets deals that Microsoft doesn't get, and Microsoft get millionaire deals that Amazon doesn't get. especially the government, the deals that come from the government. Okay, because our president doesn't like Jos Pestos, so there's some deals that Amazon could have gotten and they didn't get them. I don't know why, but when you look at the numbers, it's a lot of millions of dollars that Amazon lost. I don't know. But I don't know how this relationship works. I have no idea. Amazon has a lot of services that support third-party services, but I don't know if they just on their own create the platform and they just support it, or they have.
My hypothesis is that they're just trying to have an environment that meets you at different points in your journey. And once you're in, then they develop and push for products that has a better value proposition. So you have to use their proprietary systems.
Yeah, and I believe that once I create a platform that supports your services, if you want to be in my platform, you have to comply with certain regulations, okay, to make my platform secure. Because I'm bringing a third-party service to me, and then I'm gonna be hosting that. You have to comply. There has to be some standards that we can work together. Okay, I'm not sure how they go about that, but I'm inclined to believe that they had to sit down and talk about it before everything started. I don't know. I don't know what to tell you. But it should be somewhere there. All right, so the lab, I think you guys did it already because it's the serverless lab. Okay. Did everybody finish the lab?
Yes, I finished it.
Yep.
Mm-hmm. Yeah, this lab assigned it before because it had to do with Friday's class as well, and this one, they're both connected one way or another, because we're back to DynamoDB, which is a serverless service. We're back to S3, which is a serverless service, and we're back to Aurora, which is a hybrid. Aurora can be with the server. It can be serverless too, depending what you choose. But this is basically what you have to do, guys. And you see, this lab is more in line with Friday's class, because in Friday's class, we saw Amazon SQS, remember? And we saw SNS. Today, we didn't see that.
Mm-hmm.
Okay, so it's more in line with Friday's class. But Amazon recommends this lab for this class. Okay.
Now, today's session, we started with web services, right?
Yeah, static web, static assets, all that.
So I started with web services and how you use the different ways of saving and retrieving information from different points, S3 being one, so on and so forth. And at some point, I don't know, I got lost in the conversation for some reason, because it turns into a complete database review of different services for database services.
Yeah, because you can use the databases for the metadata. Sometimes, like I said, probably half an hour ago, it's sometimes you have a profile, and then you have to save both static assets and metadata, right? So for that, Amazon recommends using both S3 and DynamoDB, because in DynamoDB you don't store images, you store metadata. You store the name, an ID, last name, phone number. If it is a profile, maybe resume or friends or things like that. And then S3 will be for your pictures, whatever picture you upload, or if there's videos of you or demo videos of the business, whatever. So that's why they switched to,
I have a question.
they
So,
switched.
so I would have liked to see in this a progression into, and I don't know if perhaps this is not part of it, but Amplify, AWS Amplify.
It's
And then
not part, it's not part of this certification. The problem is that you have a tons of services, right?
Yeah,
And Amplify is a very new service. Amplify was, I think it was created like November, November, because I was teaching my class in October, and then I heard about Amplify that was created. It's a rather new service that is still not in the exams. When you create a new service, it takes time for that service to be in the exam because the exams have to be updated and all that. But I'm sure the Amplify may be in the new version of the solutions architect exam.
yeah, because
That's going to happen. That's going to
to
happen.
me, you know what, that was one of an important area for me because of my use case.
Okay.
So I thought it was going to be part of this.
No, it's not part because Amazon, this is all created by AWS Academy. They haven't updated this because this is intended for the exam before the July 1st.
I see.
Okay? That's why we were aiming at that. There's no,
Is there a new version of the tests that are coming up after July 1st?
yeah, July 1st,
Oh,
July 1st, version 1 expires.
I see.
And then actually they don't say expire, they say retire. It retires, and then the new version will come, and then instead of having 5 domains in the exam, you want to have 4. Okay, but the good thing about that is that the platform that I going to provide, the platform as the one that I provide in the morning, the platform that I want to provide for your exams, practice exams for this class, they cover both the first version and the second version. Okay, so you can get ready for that just in case you don't take it before July 1st, which I strongly recommend because I don't know what's coming in the other exam. I may have an idea what's coming in this one. Why do I say I may have an idea? Because every exam is different, right? I took an exam that might not be the same as you guys, as yours. But I have no idea whatsoever of what's coming after July 1st. No idea. I have heard comments from students that took the exam as well. I have my own comments, all that, but I don't know because no one has taken it. No one has taken it so far. We don't know. Students, okay. Do you have any?
Sorry.
Go
I have a question. Around what time we should schedule our exam?
Our exam should be scheduled at least 2 or 3 weeks before. We still have like 4 weeks or 5 weeks before the exam, before July 1st.
So 2-3 weeks before, yeah.
Yeah, because the problem is that there's gonna be a proctor, and I don't know how they are in terms of availability of the proctors, because you are like 15 students, so they're gonna, if you schedule it for for the same day, they're gonna have to have an availability of 15 proctors for that day. So I don't know if they have 15 proctors for the same day.
So this is for the online, taking the test online.
Right now it's online. I don't know if it all depends on the testing centers, if they're open right now. I have no idea if they're open. The one that I was taking the exams in, the one that is close to my house, they told me that in a month, that was April, and like March, mid-March, they told me in a month we'll be open. But I haven't taken any more AWS certifications since then. I have no idea. It depends.
I was taking online like 3 weeks ago.
You took
For the
what?
practitioner. For the practitioner, I was taking like 3 weeks ago, but online.
Okay.
From home.
Okay, so there was someone there, right? On Google.
Yeah, you could take the AWS exams online and at home.
No, the cloud practitioner is online at all times. Right now, the solutions architect is online because of this coronavirus. But when this is over, no more online services, no more online testing for this exam. So we have to take advantage of this. You can do it from home. You don't have to schedule it. You don't have to go out, which is not convenient at all. Okay, if you don't need it. So it will be nice to take advantage of this momentum that is happening, that, you can take it from home. It's nice. I mean, you can take it anytime. You can take it. Testing centers, they have a schedule during the day. Online, you can take it at 3 a.m., 4 a.m., 5 a.m. Sometimes they have proctors that live in China or proctors that live in another region. There's a difference in the time, and you can take it at any time. Okay, you can take it at 5 p.m. on a Saturday. You can take it at 10 a.m. on a Sunday. That's not going to happen in a testing center, especially if it is a school or any public place. Probably they work from Monday to Friday or maybe Saturday. I highly recommend, and we're going to shoot for July 1st, but you have to study, guys. You had 2 months. 2 months is enough with all the practice that you have and the exams that we're going to do together in class, and also the platform that I'm going to provide for you probably tomorrow for you to start doing the exams. You can pass. But guys, don't leave everything for the last minute. Keep the content fresh every day. While we study in class, keep it fresh. Okay, don't let the day pass by without taking a look at the PowerPoint, taking the quizzes that I give you every day, doing the labs, studying. If you're serious about this, okay? If you're not serious about this, well, there's nothing we can do. But if you're serious about this, take my recommendations. I've been there. I've been there, done that, and I know what I'm telling you. Okay? You don't need so much time to get certified. What you need is quality time. Time that you get, time that you study. You get to study. Okay? 2 months it's a long time. 2 months is plenty of time to get certified. I can tell you. All right, so remember Friday that was a little here that with the Q. Remember that I couldn't find a way to create a dead Q, a dead letter Q. Remember?
Yes.
Remember, guys? Okay, so let me see. I don't have any Qs here. No Qs. No Qs. All right, so I'm going to create a dead letter Q. Okay, so a dead letter Q is just a Q. Or Q. So I can say here my dead letter Q. Okay, and then a standard Q, right? And that's it. So configure the Q. Nothing to configure here. Okay, so I create the Q. Okay, that's my dead letter Q. Right? Now I create another Q and I name it. Okay, if the dead letter Q is a standard one, the Q, the other one, the normal one has to be standard. It cannot be a FIFO. It can be a standard. So I create another Q saying my main Q. Okay, it has to be standard. They have to match. And then here, I can configure the Q and say redrive, and then I can say here my dead letter Q. Okay, and after three times that is consumed and it's not processed, then all the messages are going to go to the letter Q. Remember, we said that the letter Q is for messages that are not processed. Okay, so it's going to tend to pull the messages 3 times, and after that, automatically all the messages are going to go to my dead letter Q. So I'm going to create the queue, and then I have the main queue here, right? So I'm going to create a message here. I'm going to create a message. Okay, send the message. Okay, this is my message, right? I'm going to send the message. Send another message. I'm going to say message 2. Send another message, and I will say message 3. Okay, and then I close it. See, I have 3 messages here. Okay, so I can do here, come to view the message. Okay, so I can view the message here, start polling messages. You see, I pull the message receive one. It was received one time. Okay, so it's just progressing here. It's receiving the message. Okay, this is the first time. After I have done this 3 times, it's gonna go to the dead letter queue automatically. It means that this is just a demo, right? It means that the message is being polled, but it's not being processed. Okay, because I don't have anyone processing. I'm gonna start polling my message again. So this is the second time. Okay, let's say that this is a consumer polling, trying to get to process the message. Okay, and let's see this message as probably like an order. Okay, in a retail store online. So it's consuming the message, you know, it's taking some time, you know. Now I'm gonna pull this again. Start polling. Boom. This is the 3rd time. So I'm just re-driving this again. And then trying to process again. I'm gonna try I'm trying 3 times, right? To process this. This is the 3rd time that I come and process this because I don't know, for some reason it's not processable. I don't know why. That will be my question if I don't know. I don't know why. So I'm trying to process this again. Okay. So I'm gonna pull it again. Good, gone. It's gone. So 3 times I tried to process that. And then if I check, let's wait for this to get to 100. If I just check, I can stop it here if I want to. I can stop here. But let's just let it get to 100. Okay. Okay, so right now, you see here, but if I refresh, you see, they were moved to the dead letter queue. So this is what happens when messages are not processed. You can create a dead letter queue, and then they will be placed here after the retries. All right. Okay. So the 30 seconds for available visibility timeout. So guys, do you have any other questions? No questions?
Not really.
Okay. Of course, this is just like isolated here. You know, this is gonna work with other services, right? But this is basically what happens behind the scene when one consumer, one component tries to consume one message in a queue, okay? But the message is nothing else than a task, okay? And this is what happens when the task is not processable after whatever number you set when you create your queue, okay? So it will be placed here. You don't lose it, right? It's still there, okay? And then you can have some mechanism to put this back here and process it again, just in case you want to process that. So I'm gonna stop the live, streaming.